Okay, so we'll finish the practice test. So these are two more radical equations. Again, we always need to start by isolating the radical, and on number 39 it's already isolated. So that means we can square both sides, because that's how you cancel out a square root, is by squaring. So the right side squaring and square rooting cancel, so we're left with 3b plus 10. The left side, a common mistake is to say that that would be b squared plus 4, but actually b plus 2 squared really means what I just wrote right there. It means that. It means multiply that whole parentheses by itself. When you FOIL this out, you get b squared plus 4b plus 4, and that's equal to 3b plus 10. Let's simplify this by subtracting 3b and 10 from both sides, and we should wind up with some sort of quadratic equation here, which usually means we can factor it. Hopefully it will factor, so we'll get b squared. 4b minus 3b is 1b, and 4 minus 10 is negative 6, and that does factor. You want numbers that multiply to negative 6 and add to 1, because that's a 1b. And the only numbers that do that, first of all, if it multiplies to a negative, 1 is positive, 1 is negative, and it'll be positive 3, negative 2. So that means b, right here, b would have to be negative 3 to make that 0. And right here, b would have to be 2 to make that 0. Okay, but again, we have to check to see if there's an extraneous solution, because we don't know that both of those will work. So let's start by checking negative 3. So we'll check negative 3 by doing, the original equation was b plus 2, so negative 3 plus 2 equals square root 3b, so 3 times negative 3 plus 10. Negative 3 plus 2 is negative 1. Does that equal this? This is negative 9 plus 10, which is 1. The square root of 1 does not equal negative 1, so that is an extraneous solution. So negative 3 is wrong. And it's impossible from time to time for both to be extraneous, so let's check this other one. So let's check 2 right here. So we'll check b equals 2, so then we'll plug in b plus 2 would be 2 plus 2 equals the square root of 3 times b. Again, the b that we're checking is 2, so this equals 4. Does that equal this? This is 6, 3 times 2 is 6, plus 10 is 16, and the square root of 16 does equal 4. So that one checks. The only solution that's working there is 2. Negative 3 is extraneous. Okay, this one is a little bit tricky, so we want to isolate the radical. There's two radicals. We should never try to square them when they're both on the same side. That would make it a lot harder. So let's move this one over to the other side. So now we have this. We have 2 plus radical 2 minus a equals radical 6 minus a. If you tried to square from at this point right here, you'd have this really messy thing that you'd have to FOIL out, which is not a good idea if you can avoid it. So now we can, at least one of the radicals is isolated. That's as much as we can isolate here, so we can square it. Squaring and square rooting cancel, so we get this. And then how do you square this? That's the same as what we did on the last problem. That's the same. Let me just box this off. That's the same as doing this right here. Foiling this out. So let's FOIL this. 2 times 2 is 4. The outer terms, use a different color here, the outer terms are going to be 2 times that, which is 2 times that radical. The inside terms are going to be 2 root a times 2, which is 2 times that again. And the last terms are going to be 2 root a times, actually I wrote that wrong, I'm sorry. It's supposed to be radical 2a, the 2 is not outside. So that is, I wrote it correctly here, but not right in the other place. So 2 root a times 2 root a is just going to be, or sorry, radical 2 minus a times radical 2 minus a. That's the same as radical 2 minus a. The whole thing squared, but squaring and square rooting cancel each other. So now we can write it like this. We can write 4 plus 2 of these plus another 2 of these would be 4 of those. And again, we're only touching the 2's in front. We're not doing anything with the stuff inside. And then this thing right here just becomes plus 2 minus a. And that's equal to 6 minus a. Alright, let's clean this up a little bit. So we have 4 plus 2 is 6 minus the a, there's the minus a, plus this thing right here. And we have that equal to 6 minus a. Let's move this stuff over to the other side. So minus 6 plus a. So when we end up doing that, we get, those are going to cancel, we get 4 times this, and that's equal to, it looks like 0. So let's divide everything by 4. We still get 0. And then now we have another radical that we can get rid of by squaring. That's always what we do when we have radicals. And that makes sense. We started with 2, so sometimes you're going to have to do this process twice. So 0 squared is 0. Let's add a to both sides, and we get a is equal to 2. So let's see if that is actually a solution, because we need to check to make sure it's not extraneous. Let's plug it back in and check to see if a really equals 2. So we have 2 equals, it's using this equation, 2 equals the square root of 6 minus 2 minus square root of 2 minus 2. So that's the square root of 4 minus the square root of 0. Square root of 4 is 2 minus 0, and that does equal 2. So it looks like 2 is a real solution, and that's it. Okay, the last problems here, these are called rational exponents. That's where you're raising to fraction exponents, like you can see right there. So we can't get at this until we clear away everything outside of it. So let's subtract the 6, so we get 343 equals this whole thing right here to the 3 halves. And it would be nice if we could just add 17, but right now we can't because we have this exponent here. So we want this thing to be to the first power. How can we make that to the first power? We can multiply by a fraction that would change that into 1. So here's what to ask yourself. 3 over 2 times what equals 1? Well, that would be times its reciprocal. So we could raise this to the 2/3 power, and we'll have to do the same to the other side. So now 3 halves times 2/3 just equals 1, and now we have an easy equation to solve a minus 17. How do you do this? This number, remember, that means what root you're taking, and this means what power you're raising to. So we're taking the cube root of 343, and there we are squaring that. We're raising it to the second power. What is the cube root of 743? What number times itself 3 times is 343? That would be 7, and 7 squared is what's left over. 7 squared is 49, so 49 equals a minus 17. We'll add 17 to both sides, and we will wind up with a equaling 66 as our answer. Okay, and usually it's a good idea to check for extraneous solutions. We did have to, this represents squaring something here, but when you do plug in 66, I'm just looking at it now, and there's no problems with that. It would work. So 66 turns out to be a solution. Alright, the last one is this one right here. So same thing, we need to clear away 2 things. We first need to get rid of that 6. So 3651 minus 6 is 3645. Okay, and now again, the idea is we need to clear away everything except the parentheses with the exponent there. So the next thing you want to do is clear away that 5 by dividing by it. 3650 divided by 5, I believe, what is that, 729, I think, 729. Let's box this off. 729 equals this thing right here. Same procedure, we need that to be to the first power, not to the 3 halves power. So we're going to raise that to its reciprocal, because that will then cancel. Whatever I do to one side, I have to do to the other. So I'm going to raise that to the 2/3. What does it mean to raise to the 2/3? It means take the cube root and raise it to the second power. You could do that in the opposite direction, but that's much harder. The 729 to the second power, it's at 531,441. That's a huge, huge number, especially if you don't have a calculator. You won't have to do that. So this is just 4x minus 27. So the cube root of 729 is 9. And then we square that to get 81. So now the last 2 things we have to do would be to add 27 to both sides. 81 plus 27 is 108, and then the last thing would be divide by 4, and we get x is equal to 27. This should not be extraneous. Let me just double check here. No, it's not going to be extraneous. It will work when you plug it in. So x equals 27. So that is the Chapter 6 practice test. Hopefully some of it was useful to you. And that's the end of that chapter.